In today's video, I am going to convert this regular refrigerator using this R134A inverter compressor to an inverter refrigerator. And I will show you the complete process of doing it. The old compressor in this refrigerator is from the Danfoss company. PTC relay is installed with these non-inverter compressors. First of all, I will test this compressor, whether it is good or bad. I will check the amperage of this compressor first of all, to know whether normal current is flowing through it or not. This is the main power wire for this refrigerator. I will install the clamp meter on this wire. I will set the knob of the clamp meter on AC amperage. This clamp by default is set on DC amperage. I have changed it to AC. Now I will power the refrigerator, and let's check what happens. The compressor is consuming 6.2 amperes, which is too high. The compressor is consuming these amperes for 10 seconds, and the compressor has powered off. Now I will remove the clamp meter. A weird sound is coming from the compressor. It seems like it is working, but sometimes it feels like it is not working. I think this compressor is mechanically bad internally. Due to this, the motor of the compressor is not able to start properly. I will remove the PTC relay attached to the compressor. It has quite heated up. I am pushing the PTC outward using a tester. It has been removed. I will now physically test this relay. But it looks fine physically. I will remove the connections from the relay. To test the relay, shake the relay with your normal hand speed. If a lot of noise is heard while shaking the relay, then directly change it and then check the compressor by powering it on. But the relay installed in this compressor is fine. So the compressor is the one which has gone bad. The overload installed inside the compressor trips the compressor when it consumes high amperage. This refrigerator has no refrigerant in it. So I will cut these pipes. But before cutting the pipes, I am using emery paper to clean the pipes. I will now pull the compressor out, because all the pipes have been detached from the compressor. I have placed the R134 inverter compressor in the refrigerator. I have braced the charging line with the suction pipe of the compressor. On the other side, the copper tubes are quite far from the compressor. The copper pipes are getting difficult to reach the discharge and the suction line of the compressor. I will braze the new copper pipes with the compressor. I will use this copper pipe for the suction side, which I have bent from one side. Now, I will start brazing the pipes to the compressor, which will make working easier later in the refrigerator. This is the smaller pipe which I will braze with the discharge line of the compressor. As I am going to install a different compressor, I will install a new filter in it. I have cut the capillary tube with the capillary cutter. I will cut the filter too, but after cleaning it with the emery paper. Let's see if the pipes I brazed on the compressor are aligned properly with the pipes of the condenser. This pipe is more in length. I will cut some of the pipe. The pipe is not inserted properly in this other pipe. That is why I am swaging the pipe. Now the pipe has been properly inserted. I will braze this pipe with the discharge of the compressor. The rest of the pipe is redundant. I will check whether it goes inside the discharge or not. It is not going inside it. I am swaging this pipe with the swaging tool as well. Now it is easily inserted in the discharge pipe. I have cleaned the pipes from the inside. My hands are oily after cleaning the pipes. You can see marks of oil over here. Let me show you from nearer. These are the marks of oil left. I have cleaned the system with nitrogen. The excess oil has come out of the pipes of the refrigerator. I did it so that the old oil would not mix with the oil of the inverter compressor, preventing the compressor from going bad quickly. I will braze all these joints. And while brazing, I put a wet cloth on the pipes to prevent the rubber flex from damaging. I will now cut the capillary from the front corner as much so that it may not choke. The opening of the capillary is quite good. Now I will install the circuit board of this inverter compressor. But for now, I have set the circuit board temporarily, and I have installed a thermostat with the circuit board directly externally to turn the compressor on and off. I will install it with the compressor. I will vacuum the refrigeration system now. I have installed the manifold and the vacuum pump with a refrigerator. The needle on the manifold is at 0 right now. I will open the valve of the manifold to make the vacuum work. I will power the vacuum pump. As I turned it on, the needle on the gauge started to go downwards. The steam is coming out of the vacuum pump. All the moisture inside the pipes of the refrigeration system is coming out as steam. The needle of the gauge has gone down completely. This means the vacuum has been completed. No steam has been coming out of the vacuum pump now. So I will close the valve of the gauge. After closing the valve, the sound of the vacuum did not change. It is the same, which indicates the system has been thoroughly vacuumed without contaminants left inside. The value on the gauge is 30 inches of mercury, which is almost 500 microns. I will now charge the refrigerant inside the system. As I place the Freon cylinder on the weight machine, I will purge the air out of the pipe hose. I will unscrew the connector of the hose to let the air out. The air is now out of the hose. I will crack the vacuum by opening the valve of the gauge. I will charge some grams of refrigerant inside the system first. I have opened the valve of the gauge. I will close it now. I will gradually charge the refrigerant inside the refrigerator. A simple R134 compressor was installed in this refrigerator. The speed of that compressor is about 1500 to 1600 RPM, which is a fixed speed. But the speed of this compressor is 4000 RPM. I will add the refrigerant according to this compressor. I will plug in the switch and turn on the button to power on the refrigerator. The compressor has not started, because the thermostat is in off condition right now. I will turn it on the thermostat. The compressor has started to work, and the needle of the gauge is moving downward. The refrigerator compressor is consuming 0.1 amperes. As we keep charging the refrigerant, the amperes will also keep increasing. I will test the freezer first. This is where the capillary of the refrigerant opens up. A gas flowing sound be heard here. Let me put the mic near to it so you may hear the sound. You heard the gas flowing sound here. This means the compressor is pumping the freon fine. It had been almost 15 to 20 minutes till I charged the refrigerant. I will charge some more grams of refrigerant in it. Now after charging more amount of refrigerant, let's see the consumption of this inverter compressor. It is consuming 0.7 amperes. The amperes of this compressor vary because the compressor varies the speed. When the refrigerant is charged in the refrigerator, the compressor at that time increases the amperes. And when the refrigerant flows in the system, then the amperes start to decrease. It has been 20 minutes. The gas I charged has been circulated in the system. It's consuming 0.4 amperes now. I have attached a digital temperature meter with the refrigerator to test the cooling of the freezer. The temperature is right now minus 1.5 degree. The ice has started to build up in the freezer. The ice has started to build up in the bottom evaporator of the refrigerator. There is no ice on this pipe of the evaporator. I will add 10 grams of refrigerant in the refrigerator. After charging 10 grams of more refrigerant, the ice started to build on this pipe which had no ice before. Now the fridge is cooling fine. Now I will check how much gas I charged in this refrigerator. I will remove the gauge hose to check it. For checking how much gas I charged, I am testing the weight of the cylinder. The weight of the cylinder is 5 kg and 980 grams. This is the weight of the cylinder before charging the refrigerant, which is almost 6 kg and 182 grams. I have almost filled the refrigerator with 210 grams of refrigerant. I will power on the refrigerator as I had turned it off while checking the weight of the cylinder. The compressor has started to work, consuming 0.5 amperes. You can see the temperature of the freezer when I started it. I will check the temperature of the freezer again after an hour. Now it's almost 1 hour and 20 minutes till the refrigerator is working. The temperature of the freezer is now minus 24 degrees. The temperature is 62 degrees of the discharge line. This temperature is okay for the discharge line. The refrigerant in the discharge line is in vapor form. In vapor form, it is warm and moves upwards. When the refrigerant reaches here in the condenser, it is still in vapor form. And I have installed the sensor to check the temperature over here. The temperature over here is 53 degrees. The temperature over here has dropped drastically. Now I am checking the temperature after 2 to 3 seconds, and the temperature has dropped 3 degrees. The temperature drops when the refrigerant passes through the condenser. When the refrigerant temperature drops, the refrigerant changes to liquid form. Now I will check the temperature over here. And the refrigerant here is already turned into liquid. The temperature here is 26.8 degrees. The temperature is 25.4 degrees. Now I am checking the temperature over here. Here, the liquid enters the filter and, after the filter, into the capillary. When the refrigerant flows through this pipe, it flows through another condenser which is below the refrigerator. The drain water of the freezer is stored on this tray. This condenser is used to evaporate the water from this tray. Other than this, it is used for cooling the refrigeration system. The temperature of this pipe is still 25 degrees. The temperature now is 70 degrees on the digital temperature meter. This temperature is on the top of the compressor. If ice is built on the suction line of the compressor, it means that the refrigerant is passing in liquid form, which is not good for the health of the compressor. In vapors, it is good for the compressor, as it cools the compressor. The temperature at the suction is 22 degrees. I don't need to charge more refrigerant in the refrigerator. That is why I am locking this pipe with the pinch-off plier. I have pressed the plier to lock the pipe. I will clamp the pipe with the second plier. I will close the pipe to do brazing on it. Now I will tell you the wiring connection of the refrigerator with this R134A inverter compressor. These brown and blue wires are the main supply wires. In the normal refrigerator, the blue wires will be directly attached to the compressor. This red wire is coming from the thermostat, which is also connected to the compressor. I will disconnect these blue and black main wires. I have made the PCB board of the compressor ready. But before that, let me show you the specifications of the compressor I have installed in the refrigerator. I have already made all the connections for the PCB ready. This connector is for the thermostat. These two wires are for the rest of the system. The main neutral and line wires will be installed here. And the earthing wire. I have soldered these wires properly as I didn't have the connector. I will install the PCB with the compressor. I will also install the earthing wire with the compressor. I will install the main and the neutral wire with the control board. The neutral wire will be installed at the top. The bottom connector is the line wire. The earthing wire with its connector. Now, I will connect the connections with the thermostat and the other two wires. I will cut the extra wire that is coming from inside the refrigerator. Now, these are the three wires that are coming from inside or going inside the refrigerator. I have installed the connectors with these three wires. This red wire is for the thermostat. I will connect this wire with the thermostat wire on the wire attached to the PCB board. The brown wire that I had soldered in the PCB board will be attached to this external brown wire. Now, this blue neutral wire is left. I will attach this blue wire with the external blue wire. Now, the important connections of this refrigerator will be made with this thermostat. I will remove all these old connections from the thermostat. I will cut this brown and white wire first of all, to disconnect them from one another. One wire is for the heater, and the other is for the light bulb. I have joined these two brown wires together. The one is the main supply wire, and the other is the light bulb wire. I will connect it with the 6 number of the thermostat. I will make these 4 wires out of the refrigerator. To create a system to make the refrigerator run properly. You just keep watching, and as the work gets completed, then I will explain what I did.
No, sígame, sígame.
Now I have done most of the work off the camera. So let me explain to you what I did. I have taken out 4 wires. The 2 of the wires are blue and brown wires. The rest of the 2 wires are gray wires. I have attached the brown wire with the white wire of the heater. The blue wire I have joined with the heater's second wire. I have given number 1 to one of the gray wires, which I have connected with this red wire. This wire will turn the compressor on and off. The other gray wire will have a direct connection. The red and the gray wire will be attached to the 4-number terminal of the thermostat. The single gray wire will be connected to the 3-number terminal of the thermostat. The thermostat connections have been completed. I will install the earthing wire with the thermostat. Now I need 2 relays, and I have written 1 and 2 numbers for each of the relays. This is a 3-pin double-sided relay which is a 220 AC volt operated. Each of its points is 5 amperes. But it has multiple pins. I will join 2 pins together which will convert it to take a 10 ampere load. Now I will explain to you about the 4 wires I made out of the refrigerator. I had given 1 number to one of the gray wires attached to the thermostat. I should have given 2 number to the second gray wire connected to the thermostat. But I knew that the other gray wire was 2 number, that is why I didn't write a second number on it. But I have given importance and given 1 and 2 numbers here on these outer wires. I did it because if a mistake is made while connecting them, the system will not work correctly. I have attached a jumper wire with the 2-number wire. But the 1-number wire is a single wire. I have installed connectors to the blue and brown wires. I have attached another blue wire with the main blue, attached to the control board. I have passed this blue wire by making a hole in the box. And I have further made 3 connections by attaching 2 jumper wires to it. I will connect these wires with the relays. First of all, I will join the neutral wires. I will start connecting it with the 1-number relay. The first neutral wire I will attach with the relay common point. The other blue wire will be attached to the pin where the relay is energized. So, I will connect it over here. The neutral connection for this number 1 relay has been completed. This blue wire coming from the thermostat will be connected to the left pin of the relay. So let's connect it. When the relay is normally off, these points will be connected with each other. This 1-number gray wire will be connected with the relay where it will energize it. The blue wire is joined with the neutral pin, and I will join the gray wire here. The connection of the first relay has been completed. Now I will connect the wires with relay number 2. First, I will connect the neutral with the relay number 2. The neutral wire will be joined with the relay energizing pin. With any of the energizing pins. This brown wire coming from the thermostat will be connected to the second pin which starts from the left side of the relay. And you can see it is normally off and the points will be disconnected. I have attached a jumper wire with the 2-number gray wire. The 1 wire will be joined with the pin which will energize the relay. This jumper wire will be joined with the common point of the relay, which from the left side is the 3rd-number pins. I have connected it. I am making sure that there is no loose connection, as it could cause a problem. Now I will cover these relays. I have put tape on both these connections. I will make small modifications to the relay connections. I will do it with the 2nd-number relay. I will disconnect this brown wire which is connected with the heater. I will install a 180 ohms power resistor, which has a power of 5 watts. I am using a 5-watt power resistor so that it may not heat up. The first pin of the resistor will be connected here. The load will run through the resistor now. The second pin of the resistor will be attached here. I will install the brown wire with the common pin of this relay. The load will now cross through this resistor. Now it has been 20 to 25 minutes since the refrigerator is working. And no problem is made while the compressor is working. The amperes of the compressor are decreasing gradually. The compressor is working at its full power. The freezer has been cooled very nicely. Ice has been made in the freezer. The ice has built on the bottom evaporator. The defrosting system will defrost this ice on this evaporator. The cooling of the refrigerator is perfect now. Click on the left video to watch the wiring diagram of this conversion. And subscribe. Thank you.